This video is going to be about a new feature I've been adding to the FITSViewer to integrate the viewer with the Simbad astronomical database. So first off, I should say thank you very much to SetiAstro, who gave me the idea to do it. If you're not familiar with SetiAstro, Frank is a guy who's been doing some great work with predominantly PixInsight scripts very recently, and one of those scripts is a script called What's in My Image, and it basically does a very similar thing. It hooks up your PixInsight image to the Simbad database to facilitate you looking at objects in the Simbad database overlaid on top of your image. So I thought when I saw that it would be a great addition to case stars, and in particular the FITSViewer. So that's what I've been doing. So I would encourage you, if you are not familiar with SetiAstro's work, to go and have a look at his website and or some of his YouTube tutorials. I'll put a link to the What's in My Image script tutorial down below in the description of this video, so you can click on that if you're not familiar and go and have a look at some of his work. So how does it work? So just a little bit of background to start. So here's a sub, one of my subs of IC410. Now if you have a few prerequisites turned on, you'll be able to see some information overlaid on this. So if you have WCS enabled, which is a mapping that exists or has existed in case stars for a while now, that facilitates mapping between the XY pixel coordinates of an image and celestial coordinates that the image is representing, so the RA and DEC. So you need to have that enabled. It does use up a little bit of compute resource, so if you're on an underpowered machine, by default that may be disabled, but I think now with modern computers generally this shouldn't eat too much of your resource, but just be aware it's a little bit resource intensive. So assuming you have all of that turned on, what you should be able to do on the FITSViewer is click on this Show Objects in Image button, and it'll go off to the sky map and it'll show overlaid on the image anything of interest. So not too much in this one, just it looks like there's a couple of items there. So that's been in the FITSViewer for quite a while. So what I've done is extend that. So back to the options here. If we change sky map here and use the Simbad catalog, now when I do this query, it'll go off and query over the internet, so you do need an internet connection for this to work. It'll go off and query the online Simbad database. Now by default it'll query it for 1 arc minute in the center of the image, but you can basically choose any area that you want. So I'm going to hold the shift key down, click on this star and just drag a circle and release, and it's gone off and found 10 objects around this particular star here. So you can query wherever you want. Just do another one and it'll go and do its thing. Be aware, if you query a large area, it's going to pull back potentially thousands of objects of data, so it will take a while. But other than that, you should be able to query whatever area of your image you want. So what does it actually brought back? So the Simbad database is an online database, and if I just double click on this Simbad item, it will launch a web page on the Simbad website for this particular object, Gaia DR3, etc, etc. So if I do that, so it takes you to this web page here, simbad.u strasbourg.france, and it has queried the database for this particular object. So you can see it has coordinates, some flux information, you know, etc, etc. So it's all quite interesting. And what this does, in what I've implemented in the FITSViewer, is kind of a way to represent that within the FITSViewer. So you have a similar set of information. You have the name of the object, you have its type, code and label, and a little bit more on that in a few seconds. The coordinates, you have the distance in arcseconds from the center of the query. If the object has a magnitude in the database, it'll display it here, and if it has a size in the database, it'll display it there. The magnitude, incidentally, is what Simbad calls the V magnitude, so I guess that's a visible magnitude. So obviously the magnitude will depend to some degree on the band that you're considering. So that's kind of the basics of the data it pulls back. You can, if you click this show names, it will show the names of the objects on the FITS image. Obviously, if there's a few, it's fine. If there's thousands, it's just a big green blur, so it's not very helpful. So you can toggle it on and off as to whichever you prefer. If you click an item here on the image, it'll highlight the corresponding item in the table, and if you click an item in the table, it'll highlight the corresponding item on the FITS image, so you can keep those two in lockstep. The other button here, called filter, brings up a filter to let you filter on types of object. So back to the Simbad web page, they have a if I click on this object types, they have an explanation object types web page. Now this is really their taxonomy of celestial objects. So every item in their database has a type. Now if I, you know, these are the sort of the top level types of objects, so stars, clusters, sets of stars, so things like clusters, interstellar medium, galaxies, sets of galaxies, and then some stuff on gravitation, blah blah blah, etc. If I open, let's say, stars, the next layer down are, you know, well, young stellar objects, main sequence, stars that have evolved beyond the main sequence, chemically peculiar stars, love that name, etc, etc. So and then under each of these there's a series of subcategories, you know, etc, etc. So this is sort of a tree structure of types of object. So for example, these SX PHEV star type objects are a subcategory of blue straggler, which itself is a subcategory of the main sequence, which itself is a subcategory of stars. So this is the way that the Simbad database is organized, and you can query based on object type. So if I go back to the FITSViewer, I've implemented pretty much that taxonomy here within the filter pop-up. So top layer here is stars. You've got your massive stars, your young stellar objects, main sequence stars. Within that you've got your blue stragglers, and within that you've got this SX PHEV star. So this filter pop-up mimics the Simbad taxonomy that they have on their web page. So this enables you to basically query based on object types. If you're particularly interested to see if there's a certain object type within your image, you can select that type and you can see if it's there. So just to show you how it works, by default nothing is checked, and nothing being checked is the same as everything being selected. So if I was to check everything or uncheck everything, that means the same thing, i.e. give me everything, don't filter out any particular types of object. If I was to select, let's just say, stars, it will also select all the subcategories under star. Now if I didn't want this SXPHEV type, I could uncheck it, and obviously it wouldn't include it in the searches. So you can just toggle them; they just toggle on and off. So if I want to look at all the stars, I can just apply that. Now these happen to be also stars, so it's not done anything particularly interesting. But if I, for example, just wanted main sequence stars, let's say, I could do that, and I've just got this one item left because all of the other stars that we previously saw are not main sequence stars. So you can play around with this and, as I say, select things that are of interest to you. So just undo that and apply it again, and back come all the objects. So that's the basics of how you query. So let's have a look at a couple of other options. So if I open up another item, let's have a look at, let's try this one. I think this is the elephant trunk. Yes, okay. So this is a sub for the elephant trunk nebula. What I'll do is I'll demonstrate one thing that will probably depend a little bit on your quality of your imaging equipment. So when a sub comes in, it will have populated in the FITS keywords a whole raft of information about the pixel size, the binning, the etc. That provides a lot of information, of metadata about the image. Also provides information that facilitates the WCS functionality to work out celestial coordinates based on the RA index that's been populated when the image was taken and put into the FITS header. Now, I suspect if you have a high quality imaging rig, that the RA index are probably quite close to what you get from plate solving. In my case, they're close, but they're not super close. So they're good enough to facilitate a lot of processing, but they're not 100% accurate. So what you can do to get things a little bit more accurate is use the plate solving tab on the FITSViewer, which Hi built in not so long ago. Now, if you bring up the tab, what you can do is you can do a blind solve where you don't give it any clue as to what the scale and the position is, and it will go off and search the catalogues as best it can. Now that can work sometimes, and sometimes it can fail because you've not really given it much help in terms of where to look for the solution. So You can try that, and sometimes, as I say, it works, sometimes not so much. What you can do to improve it a little bit is, I happen to know that this is the scale of the scope I used to take this, so I can use that as a hint by checking that box. The other thing you can do, which is quite useful, elephant trunk I've selected in the sky map, so that's IC 1396. So if I use this button here, it'll take the coordinates from the sky map and populate them here. And then if I check that, when I press solve, I'm giving it a clue as to the scale. So I'm saying use this, which I happen to know is about right for my equipment, and I'm giving it a hint as to the RN deck position, which I've used from the sky map. So if I click that, it's found a bunch of stars and it's solved. Now, what I can do, having basically solved, is it will also update the FITS header information with the results of the solution, which will, when I go back to look at the catalogue objects by clicking that button, it will have a much more accurate view on where the image actually is. So one of the things I was doing not so long ago was I was looking at the 2 stars inside the hole in the elephant trunk. So if I just zoom in on that, okay, there's one here. So if I just do a slightly bigger one there and zoom in a bit, you can see there's probably a star there, and there's, I think it's this one, yeah, that one. Let's just take the names off, be slightly more, yeah, so there you can see hopefully that the red square around that star, that's the most visible star in the elephant trunk. Now if I look at that, it's telling me this is an Orion variable star. So if I were to go off to Simbad, you can get a bit more information about it, and you can look at reference, academic references to that particular star, etc. The other thing I quite like to do, just get rid of this, is if you have a look at the CDS portal, again for that star in the middle of the elephant's trunk, you can see, so I zoom this, yeah, there we go. This is a program called Aladdin Lite, which is a web browser version of the CDS's Aladdin program, which is sort of a visual way to query the Simbad database. You can see that it is actually the right star. It's the brighter one of the 2 in the elephant trunk. And again, you've got loads more information here if you're interested in this particular star. Go and look at plenty of stuff. So well, I won't go into that much more. So that's quite useful. So if I bring up the filter, what you'd expect from the elephant trunk, because it's a big region of nebulosity, is there'd be a lot of young stellar objects. So these Orion variable stars are some subset of the young stellar objects in Simbad's database. So that's kind of what you would have expected. So again, if you wanted to look for them, you could just select that, apply it, and we've got one in this particular frame, but if I was to query again, you may end up seeing a lot more. So that's how to basically do queries on subframes. So the other thing that you can use this for is you can import finished images, not just subs. So here's one I prepared earlier. So this is an xisf, so it's come straight out of PixInsight as a sort of a completed image. Colours are a bit odd there, but anyway. So this is Thor's helmet, obviously, and it's it's a non-linear image, etc. Now, because it's an xisf, that format supports a whole bunch of header information, which is displayed in the FITSViewer. Oops, wrong button. As a load of FITS header type information, although it's obviously not a FITS file. Very similarly to a FITS sub. So you have information about the RA and DEC. So again, once more, because you have that information, you can you can sort of query the catalog for it. And the colours are a little bit brighter now, so it's not quite so easy to see the green circle, but if I just zoom in a bit, you can do a very similar thing to what I was doing earlier. Just do another query and it'll pull out stuff, so you can go and have a look at what's in your particular image. So that's xisf files. You can also do JPEGs and other types of files that the FITSViewer will support. So here's another picture of M81. This is again obviously a non-linear image. Now, because it's a JPEG, if I go look at the FITS header, it's blank, i.e. there's no metadata. So in this case, I have to plate solve in order to use the catalog functionality. Now, it's grayed out. This show objects button is grayed out because WCS can't work, because there's no FITS header telling it the RA and DEC. So you're forced at this point to plate solve. Now, what I should do is give it another clue. So if I go back and just put M81 into the sky map, come back here, I can query the sky map to get the coordinates roughly right, and I can attempt to plate solve. Now, I've chosen this particular image because it highlights something that you may or may not have trouble with. So it's failed to extract properly, and although it has solved, often you'll see that there are potentially some issues with plate solving fully processed images that are no longer in the linear state. So what I've added here is this linear image checkbox, which will give a boost to non-linear images if you uncheck it, in order to improve the star detection. So I don't think you'll always need it, but if you have images and they're plate solving fine, then it won't really be a problem, and you won't need to use this. But if you do have problems plate solving non-linear images, you might just want to try it with this and see if it works. It's going to be a little bit of playing around with parameters, so I may not have got it 100% right. It seemed to work quite well on the images I was trying, my own images, but if anyone does have problems with it, just drop a note onto the forum, and happy to take a look and if necessary adjust the way this works a little bit if it could be improved. So anyway, just have another go at solving it. So it has actually found some stars this time with unchecking of the linear image checkbox. It has solved. So You won't actually see any FITS header information, it doesn't populate it, but it has stored the information in such a way that WCS now knows enough about the image to be able to know where each of the pixels or what each of the pixels is representing in terms of celestial coordinates. So I can now click this and it should go off and query the Simbad database. So just so happens hasn't found anything right in the center, which is interesting in itself perhaps. But if I was to maybe pick a slightly different area, there's quite a lot of stuff there. So I can sort of zoom in a bit and take those names off because they're getting in the way. See what that is. That star there is some sort of molecular cloud, not a star. So interesting. So anyway, that's kind of a quick overview of how this functionality works. Hope you find it interesting. I guess the only other thing to say is it is in beta at the moment, so it's available in the bleeding edge version of K-Stars. Should be released in 3.7.4 when that goes out in a couple of months. So hope you find it interesting and clear skies.